record for you and for the students who are not with us, but basically for you to go over, not the whole thing, I hope, because it's basically a bit long, but at least to go over some parts of it, okay? Let me check on the participants and on the chats so I can follow up with everyone. Yeah, I can see that we are 15 participants. Not bad. And probably we can start. Do you have any comments related to the assignment? I see probably 4 students did not submit yet. Are you having difficulties? Do you want us to discuss something? Do you need more time? Okay, Karin, leave and come back. So, I need to know how's it going with the assignment. Why? Okay, listen, let me come back. I'm the only adult in here. Something funny? What did you say? All right. So, I was asking.
This I will buy.
Say it again.
This I will buy.
مش عم بسمع.
This يعني طبعا الاشتراك التي في او الباي والكهرباء يعني
لا
في غيره الوحيد بيجي ستار.
يا مان كنا عم بعمل recording للسيشن not your class. In some other schools I do actually record for the admin not for the students. وبصير في انفجار بالبيت وراي. So back to you, the assignment. So how come 4 of you did not submit, and was it difficult on you? Yesterday I was thinking that probably the way I approached data analysis was a bit fast and a bit difficult on you, and I was thinking about Lean. I've never heard of Lean this week. Lean, are you there? Are you doing okay?
Yes, I'm here.
Are you sure? I was expecting you to text me or to contact me probably for us to meet or discuss stuff. Do you need help? Let me help you, please.
No, Sharbel is helping me.
All right. Sharbel, thank you for the help. So,
doctor.
Okay, so I remember we did data analysis too, but it was so quick and I promised to go over it again. This is data analysis too, what you need to know, all right? I'm gonna skip all the introduction, and I mean by introduction, the way I've been dealing with, but the basic, probably you should know the basic purpose of this introduction. It is, please, every time you plot something, make sure to show a title, to label your axis, to show a unit, and to make to show a clear legend. It doesn't have to be an official legend, but we should understand what we mean by graph 1 and graph 2. The title could help though, all right? So that's what the introduction is about. Next, we discussed linear and non-linear. I think we went over this, or it was not with your class. We went over this very quick with you. And we said that any relationship can be made linear. If we don't want to plot T versus L, we can plot T square versus L. Iman, I'm gonna check what you wrote in a minute. And the most important thing is how to do linear regression, okay? And then we said, please do not use y2 minus y1 over x2 minus x1, only because the points are not on the line. The points are actually scattered around the line, like in this case. So you don't know which points will be on the line, and you do not actually know where the line is. So the best way to find the slope is to actually do linear regression, and please do not do this. All right? And how do we do linear regression? The easiest way is to throw your values on an Excel sheet and insert a scatter, and then right-click to the scatter and add a trend line, add equation. It will show you the equation like in here, the equation of a straight line. You take the slope from it. You can look at the R-squared function. It has to be very close to 1. So 0.9 is acceptable, I would say. Now we've been discussing using the calculator to find the slope, and here you express the fact that you think that using Excel is so much easier, okay? And you don't want to use the calculator, and I was okay with it. All right, next is, I asked you to try this out. Did you do it? Did you manage to do it? I had a quick look in your assignment and I believe it was there. So I'm gonna check now what you did and probably leave some comments with you. And no, I'm not gonna grade you. And this is something that probably we discussed, that how to, like those relationships could be linear or not, and how to make them linear or not, yeah? Yes, of course, Yara. The purpose why we're trying to drift away from the calculator is if you are on campus or you're not on campus, you will actually have the luxury to use Excel, because I believe all the exams will be computer based. So even if you are on campus. Let me continue. Error on the slope was an issue. And here we came up with many methods to find the error on the slope. One, you need to understand why you have an error on the slope, and it's basically due to the scattering you have around the straight line. And we are basically interested by the vertical deviation and not the horizontal deviation. And we reached this point. I sent you the video and I'm gonna show you where exactly, because probably some students are not aware of that. And we've been using the equation, yeah, this equation that you already got used to, and this was something for you to try. All right, now I'm gonna go to your actual Blackboard that is here, and let me move it. I got it like that just for me to catch up on your names. So for data analysis, what you can find, and I hope you had the time to go through all that, PowerPoint 1 was actually, thank you, Habibi. PowerPoint 1 was actually the data analysis first part. PowerPoint 2 was data analysis second part. This is the assignment. So if you need any extension of the deadline, let me know, it's okay. This is where you submit. And somebody told me that you cannot submit many times. Is that true? All right. Usually and always, I make sure they can submit many times. Let me check. Probably I did not do that, and I'm gonna do it now for you. It's gonna be unlimited attempts, okay? Heike, you don't need to email me your work, you can submit again. And I'm gonna, all right. So since this is not graded, I'm not gonna look into the grade. Those are what's in black are YouTube videos. So how do you find the error on an average? Using probably a calculator and the equation as well. Calculate the slope using a calculator. How do you find the error on the slope? And you have the Linus method. Many of you probably heard of the Linus method last semester while we did Physics 302. You don't have to use it. Personally, I never use it, but I know it's very fast. So if you got used to it, if you get used to it, I think you will never ever gonna use the equation for the error anymore. All right, so Yara, you tried the Linus method and it couldn't work with you. Yeah. Yara, I urge you to meet with me so we can try it together. Okay? So probably...
No, Dr. Arman, I tried to resubmit and it didn't work.
Okay, now. The resubmit. I just edit the resubmit. It was submit only once. And usually, like always, I'm gonna put it unlimited, because I assume all these assignments are something for you to try and improve. I want you to try and submit again. Sometimes it's okay to submit again. That's not a final exam. Yes, Anna, tell me.
Doctor, when we use Excel in the reports or assignments, I directly said, using Excel and I put the answer. Should I include anything else, like show you mobile?
Listen, it's up to you. Remember, those lab reports are a mini research. Why not show your hard work? So the best would be to take a screenshot of the part of the spreadsheet you want to show, and it's going to be like a picture, and insert in your document. I think it's nice to show your work, unless it's not worth it. It probably sometimes you do a simple calculation on Excel and you don't really want to show it because it's not worth it. Yes, you can insert. Basically, I insert as an image, so I take screenshots a lot, insert image. This is what I do. I know there's a friendship between Microsoft Word and Microsoft Excel, so you can easily copy paste, I believe, but don't go through this. You don't have to screenshot, crop well, insert image. I think it works better, and you are in control of your boundaries and margins, I think. There's someone who wrote me a text a few seconds ago. Iman, I want to read what's wrong with Iman. So Iman said, I was not good with data analysis since I did not do well. So I believe you have some gaps. All right, so Iman, watching YouTube videos will actually help, although I believe it's not enough. It's important for you to try and try alone without your partner and make sure to fill in your gaps. And please, people, you need to understand that it's important for us to meet whenever you need us to meet. All right, so Iman, if you believe you have any question and you need to meet for any reason, let me know. I can see that Abdo as well is proposing to help you. So yeah, whatever, just make sure you fill in the gaps as soon as possible. Can we always use the line instead of the equation? Of course, Hussein. Who am I to tell you what method to use? The Linus method and the equation will actually give you the exact same answer. Okay. All right. What else? If I miss any chat or question on the chat, let me know. All right, so do you believe we should take more time for data analysis? Personally, I'm not happy with the way we went through it. But now that we did, do you have any question? I'm gonna move on to our first experiment, but please, I'm assuming if you have any issue, meet with me again, all right? We can sit for 20 minutes, for 30 minutes. We can sit for 1 hour if you need us to. Fine, and we can meet as a group meet if you need us to meet not privately. All right, so on the syllabus, our first experiment is electric field mapping. I'm gonna discuss the theory. I'm gonna start with whatever you know from high school, not whatever you know from the course, because I really need to target your conceptual understanding, all right? And then I'm gonna discuss the experiment. I'm a bit scared that the experiment would not be very clear, so I'm gonna take my time on this one. Also, I need to warn you or probably tell you that in this experiment, you don't have to do any data analysis and probably no calculation, nothing. You just need to do a very simple measurement to create a map, and then you're gonna discuss the map and answer some conceptual questions about, let me call them qualitative approach and not really a quantitative approach. And sometimes students would feel this is frustrating because it's easier when you have values and you do the calculations, you feel so much better. So let me try my best to show you the whole thing without any confusion. All right, so let me see what we have. I'm gonna start with some slides that are basically empty, and probably together we can fill them in. Equipotential lines and electric field mapping. Our purpose is to know the map of the electric field, but as you know, there's no way we can measure the electric field. This color is not great here. Let me use something less mild. This is all right. All right, so I was saying that the purpose is to target electric field mapping, but since we cannot measure electric field, we'd rather start by creating a map of the equipotential lines and then try to deduce the electric field lines. I have some questions and probably I can go to Blackboard, get your names. This would help me communicate with you. And no, I under no purpose, I'm here to stress you out. Okay, this is for me just to learn your names. All right, probably I can ask Roy. Roy, how do you think, or what measuring tool do you think would help me to identify an equipotential line? Do you have an idea? Can you guess? And it's okay if you don't know. Is Roy with us? I think he is.
Yes, I'm here, doctor.
Yeah, so equipotential line, what do you think a measuring tool would help?
I actually don't have any idea.
Probably to measure the potential. Any measuring tool you can think of to measure the potential? Electric potential?
Voltmeter or not?
Right. Yes, so Karin, Yara, and you are saying voltmeter. Yes, I'm gonna use a very simple voltmeter. with 2 decimals and probably less to find the potential difference. Digital, yes, we don't have analog voltmeters in the lab. Now, if I have a voltmeter, how do I know if 2 points are on the same equipotential line? Do you have an idea? So 2 points on the same equipotential line. If I use a voltmeter, same potential. So what will the voltmeter give me? You know, the voltmeter does not measure potential. It measures
the difference.
Yes.
So there won't be any difference. So it will display 0.
Exactly, it's gonna display 0. So I'm gonna use the voltmeter and find zeros on my map. This is all I'm gonna measure in this experiment. Thank you, Roy. Now back to Maria. Maria, do you remember, or can you think of, and it's okay if you don't remember, can you think of a method to deduce electric field lines from equipotential lines? Do you have an idea how they are related? How are they related?
No, doctor, I don't.
Okay, anyone in this room would think of a relationship between equipotential lines and electric field lines? No idea. Perpendicular, yes, probably. Let us go.
Equipotential, doctor.
Yes, Sharbel.
Equipotential lines are يعني مثلا بيكون عندنا 20 فولت بيرجع 15 فولت بيرجع 10 فولت بيرجع 5 فولت.
So each line has a potential, volt, that's true.
Moreover, on each potential مثلا on 15 volt, wherever we put a point, whatever the amplitude will be, رح يضل عنا إنه it's 15 volt. يعني we don't care about the level of height أو مش of height. يعني نحن هيك شفناها بالكورس.
Okay.
بس
yes.
علي.
Yes. What about the electric field lines? How are they related to equipotential lines?
They are perpendicular.
All right, so now in the coming slides, I'm going to discuss very simple stuff, okay? I'm going to start with a field. You know what is a field? And what are the different fields you've been introduced to since that day, like until this day? So how can you define a field? So you know the gravitational field, you know the electric field. Anything else? Magnetic field. How do you define a field? It's there, you cannot see it, you cannot touch it, you cannot smell it. It's in a certain space. And yes, you can have gravitational, electric, magnetic field in vacuum. How do you know it exists? Like, am I sitting now in an electric field? How do I know? Explain, Iman. What do you mean by forces? A place affected by a force. I place a point charge. So you need, yes, Karen, you need to test to be able to know if the field exists. So you need to get a test charge and put it in the field and release the charge and see if it moves in a certain direction. I'm going to say yes, an electric field exists. And if I need to know if there is gravitational field, I put a test mass and I release it, and I would see that it's going to move in the direction of the gravitational field. So yes, a gravitational field exists. So I need a test charge or a test mass to know if it exists or not. All right, so here you have a source. I'm comparing a bit the gravitational field to the electric field. For the gravitational field, you need a source, and usually it has to be a massive object, a planet, a star, the moon, something massive. And you see around it, you have electric field lines, gravitational field lines. They're always radial and inwards, you see? And we say that the force of gravity is m times g, and g, the gravitational field strength, or the field, is g, mass of the source. This is the gravitational constant over distance squared. If you look at the electric field, you see that you have two cases. You can have a positive source or a negative source. In the case of the positive source, you see the electric field is radial but outward. And in this case, the electric field is radial but inward. And yes, the force is test charge times the electric field, and the electric field is K, you can call it electric constant, which is 9 times 10 to the 9 if you take it SI units, and if you take it one significant figure, yes?
R second carré.
Yes, or you can simply say SI units. And then this is Q of the source and distance squared. And you can see they're actually very related. And you know the famous meme that Coulomb's actually was cheating from Newton? Have you ever saw this meme? Because the equations look very similar. Probably you're not into nerdy memes. Maybe you find them a bit boring. But you see test mass, test charge, gravitational field, electric field. And here for the field, you have constant source over d squared, constant source over d squared, radial both ways. Positive is outward, negative is inward. So the gravitational, like the mass, the source is probably similar to a negative charge. I don't know, it's the way you see it. Here you see three different charges. Let me move the chat to the side because I want to see the whole slide. Okay, and keep this as such.
They can create, if they're انجمعوا سوا, they will create a dipole as a positive مع negative electric field.
Yes, this is interesting. Probably, Sharbel, you can tell me what's the difference between A, B, and C if you look at electric field lines.
Oh, okay. As we know from the previous equation, A times Q over. So if in the first one, the distance and the electric field is a bit small, because we can see that the distance between the arrows is bigger than the distance between the arrows in B.
Sharbel,
so the electric field in B is larger than A.
Okay, Sharbel is saying since the electric field lines are spaced out, it means that I have a weak electric field and I have here a strong electric field. And what's the difference between A, B, and C as being the source charge? Somebody's telling me, Iman, discussing the strength, stronger electric field, more field lines. Yeah, but what about the sources? A, B, and C. How come C is giving me a stronger field, but A is giving me a weaker field? Due to what?
Charge.
All right, so different Q. Okay, so I'm gonna say QC is greater than QA. And actually the electric field lines are, the number of lines is proportional to the strength of the field. I can see more lines in here, less lines in here. What about positive, negative? Which charge is positive and which is negative?
Column positive.
How do you know?
And toward away from the charge, not inward to
all right,
to the charge.
Since, yeah, because the electric field is outward. Okay. In this case, you see two sources, plus, plus, creating. So what you see here is not E1, neither E2, it's E resultant. All right. And basically, you do have electric field here created by E1, which is like this. Okay, now let me make sure that this is charge 2. This is charge 1. E1 is going to be outward, and this is E2, and they're actually equal and opposite. They do cancel out. In other words, you have no resultant electric field in this region. That's why you have an emptiness. So what you see here is neither E1, neither E2. What you see actually is E1 and E2 combined, being vectors, and this is how the shape of the map will look like. In the case where you have a negative charge and a positive charge, what you see here is neither E1, neither E2, but the resultant of both charge. So this is E total. And by the way, the E vector is parallel to the electric field line. So at this point, this is how the E vector is. At this point, this is how the E vector is. I'm talking E resultant, the total. At this point, this is how E vector is. So make it tangent to the lines. All right? Also, you can look at this map and discuss a bit the strength. The closer you are to the source, I can see more density of lines and therefore stronger. Here I see the density is less and therefore the electric field is less as you go away from it. And you can see here they're actually not very dense, and you can see some weak field in this region. So the map is actually a very good description of strength, of magnitude, of positive or negative charge, and of interaction between different charges. All right. So here I'm going to take some values and let me remove those. I wanted to remove them before I see you. Probably I forgot this one. Okay. Whatever. And let me remove all this. The question is, and probably change the question, what happens if you put a proton at point A? I'm gonna pick this to be point A, okay? So what happens?
It will move towards the charge, towards the negative charge.
Okay, so what you're trying to say is that the proton is gonna move along the field.
Yes.
So if the field is inward, the proton moves inward. However, on another note, we know that the proton moves from high potential to low potential, and this is a fact. So which point has more potential, A or B?
A has more potential.
Okay, so let's type it out. I'm gonna say that the proton, I'm gonna say it will move along the field. In other words, toward the source. This is one idea. Another idea is it will move from high potential to low potential. That's idea number 2. Another idea would be the potential of A, so VA is greater than VB. All right?
Doctor?
Yes. Just call me Jesse, please.
البوتنشال على B مش أكبر من البوتنشال على A.
Why?
لأن B is يعني أقرب للكيوب من A.
Yeah, but Q is negative. So it's like, it's as if you're moving from 0 to a more negative answer. So it says, so when I say VB is smaller, not an absolute value. It is smaller and since VB is more negative than VA, that's why VB is smaller than VA. Probably in absolute value, it's bigger than VA. All right? All right, I do understand. Now I'm gonna pick point B and point C. Point B and point C are like this. I'm gonna put a proton at point B. Do you think the proton will ever have the chance to travel to point C? Yes or no, and why not, and why not? Okay, so Yara's saying the proton cannot travel from B to C because the proton will move from high potential to low potential, and it's gonna move. So we have two ideas. The proton must move from high to low potential, and it must move along the field. In other words, it cannot move from B to C. Therefore, B and C will have the same potential. So I'm gonna come up with the conclusion that the potential of B is equal to the potential of C. So what I'm trying to do here, I'm trying to explain potential, assuming you don't know what potential is. But obviously, I can tell that you know the potential and you know the equation for potential, and you don't need me to use common sense to tell you why VB is equal to VC. You know it from the equation, and you know it's KQ over R, and it's R dependent. All right, so the point behind this slide is for you to understand that any 2 points or any line perpendicular to the field will give you all the points at the same potential. This is the thing I want us to reach. Now, what is with this slide? What are equipotential lines? Equipotential lines are lines. Yes, somebody's raising. Yes, Roy.
Yes, could you just repeat the property that you just said about being perpendicular?
Okay, so I was assuming I wanted to use the fact that you don't know what the potential is and you don't know what potential difference is. And my plan was the following. We said that the proton will move from A to the source due to the fact that proton is simply attracted by the negative charge. And then we said the proton should move from high potential to low potential, and we came up with a conclusion that potential of A is greater than potential of B. And then we said the proton should move along the field. So there's no way the proton would move from B to C because this is traveling perpendicular to the field. We know that the proton must follow the field. Like any object you throw without initial speed, it has to go along the gravitational field. It cannot travel. If you throw your phone, it will never ever travel parallel to the floor. It has to travel towards the floor, right? Because this is how nature of things are. So since the proton must travel from high potential to low potential, and it cannot travel from B to C, neither from C to B, we come up with the conclusion that B and C, they have the same potential. All right, because traveling perpendicular to the field is not possible. So any line perpendicular to the field will give you points at the same potential. So conclusion, equipotential lines or lines that are a set of points of the same potential must be, by definition, perpendicular to the field. Because if you go along the field, the potential is getting lower and lower. So if you go perpendicular to the field, the potential cannot increase, cannot decrease. It has to remain constant. Remain constant means equipotential line. Okay, I'm just trying to use some common sense, assuming or trying to use something that you know from grade 11 high school. All right, but since you did the course already and probably covered potential in the course by now, we are at the end of February, so all this is already easy on you. But it's always good to go back to a different perspective. Did I answer your question, Roy? Yes?
Yes, thank you.
All right, so here what do we have? I went back to the electric field lines. The blue lines are electric field lines, and the detached lines are the equipotential lines. And you will see that, all right, let me move like this, and you will see that any 2 points on an equipotential line, those 2 points will have the same potential. And you see the map, how it looks like here, it's perpendicular at any moment, and perpendicular at any moment means a lot. Let me show you, because this is some confusion. So here you see perpendicular. Here you have perpendicular. So as the blue line will curve, the gray line will curve with it. Okay, so you see when you have a high curvature of the blue lines, and this will have a will give a high curvature for the gray lines. You see how they are related? When you have a radial behavior of the blue lines, you will have a circular behavior of the gray lines. So radial for the blue will give you circular for the gray. And when you have horizontal lines for the blue, you will end up with a vertical line for the gray, okay? Yes, and in this case, where you have 2 positive charges in a close proximity, you will see radial behavior, circular equipotential lines, and here you have nothing in here. You can see perpendicular behavior, and eventually it's a sketch, it's a map. Sometimes you're very close to a perpendicular. Like here, it shows to be a bit around 100 degrees and not 90 degrees, okay? It's a sketch eventually. So what you're gonna do in this experiment, you're gonna draw the gray lines and deduce the blue lines by simply following the perpendicular bit by bit. But you will be given this example, like a very easy example, just for us not to be confused. All right, and these are general examples to follow. I think that's it. These are equipotential lines. You see each line is given 1 potential. So all this line is negative 2 kilovolts. I don't know where the source is. It's basically created by some random source. You will see that all the points here, they have the same potential. The potential difference between the points is 0, but the potential of each is negative 2 kilovolts. Here they said potential 0, potential 1, potential 3. So you see an increase of potential as you go in this direction. So just for you to see how equipotential lines would look like. Now let me try to go back to our plan. Let's assume we're done with the theory, although I'm ready to come back to it anytime you want. And let me show you the experiment, because you need to understand the procedure a bit. I remember back in the lab, students took some time to understand how to draw the map. I hope the video will be clear. This is an actual video and not a link. I'm gonna send you the link, which will be less, at a lower resolution probably. Probably this is the first video I did back in the fall. So I'm sorry if I sounded a bit cheesy, you know, I'm a shy person in front of the camera. I'm not gonna play it because you can play it later. I want to show you the equipment, okay? So what you have here, you have the voltmeter, and I'm gonna use a test voltmeter, which is a really cheap voltmeter that will be accurate enough for this experiment. The brown board is a cork board, like any bulletin board you had back in school. I don't know if you still have them. The black paper is a conductive paper. And by conductive paper, it means I can simply have equipotential, a potential difference across it once I create two sources. In a moment, you will see I have 4 banana wires, 2 of which will be attached to a power supply that is here. I'm going to show it to you in a moment. The power supply is a DC power supply, and I will use 20 volts. That is not too high and not too low, so enough to do the experiment, to do the measurements. I'm going to use pins. Let me see if I show you how to do it. So here I'm explaining how to use the voltmeter. I'm showing you which scale I'm gonna pick. Okay, those 2 banana wires are attached to the power supply, and those 2 banana wires will only be used to do the measurements. And this is how the power supply looks like. It's somehow heavy. I'm gonna put it on 20 volts. How do I know it's 20 volts? It's gonna be approximate because you can see an analog measuring tool in here. Although we have other ones like this in here to be digital, but it doesn't really matter because I'm looking for zeros and the order of magnitude is what matters to me. So I want it to be around 20, 19 would work, 21 would work, all right? So I don't care what the value is as long as it's constant, because if it's not constant, it's gonna be confusing. Okay, heavy back to its position. All right, so now this is the cork board. This is the conductive paper. Usually when the students would poke them with a pin, we give you a new one to do the experiment on. All right, so here I'm gonna use pins. Where are the pins? All right, so you see those pins attached like simple punaises, but these are conductive pins. All right, attached to the, so whenever I put 20 volts as a potential difference on the power supply, I would have 20 volts between the pins. And I will measure in a voltmeter. You will see it's basically 20, right? So now I'm gonna poke the paper nicely and in a symmetrical way, like I'm gonna, yeah. By the way, the paper has a grid line and the smallest subdivision is 1 centimeter. So the analog measuring tool, smallest subdivision 1 centimeter divided by 2 is the uncertainty. So you're gonna see on the paper, on the map, the coordinates to be with 1 decimal, not more, because I cannot estimate more than 1 decimal, okay? And this is only y-axis, x-axis in centimeters. So that's it for the first video. In the second video, I divided the video into 2 just to show you how to start, or probably the equipment and then the experiment. It's a continuation actually to show you that the red, listen to the video. You need to know if the red is on the positive terminal or the negative terminal, because this is a source of charge, right? It's a point-like source. And the blue is another point-like source that is either positive or negative. All I know that the difference is 20. So probably potential plus 10 minus 10, difference 20, or plus 25 minus 5, plus 5, the difference is 20. I just know that the difference is 20. So when I call them positive, negative, probably one is 0 and the other one is positive. Probably I should say high potential, low potential, or VA greater than VB. Now I'm gonna get the voltmeter. Where's the voltmeter? Okay, now I'm gonna show you which scale I use, probably to use 2 decimals. 2 decimals are enough. I'm gonna look for zeros. If I put more than 2 decimals, it's gonna be frustrating, because if you would move by a simple millimeter, it's gonna change. And since your grid line is not very precise, why seek precision for the potential difference? Be reasonable, okay? Because if you move your pins on the paper by a fraction of a millimeter and it's gonna change your voltmeter, you cannot say the coordinates. For you, the coordinates are gonna be the same. And it will be so time consuming to create the map. So 2 decimals are enough. Probably this is what I said in the video. Now I'm gonna pick the scale needed. So here I'm discussing the scale, use the banana wires. All right, so there's now a tiny confusing idea. All right, here I'm measuring both pins. I should get something 19, but I will not because this was off. So I turned it on and I got something 19, you see, 19.9 volts. Basically very close to 20. As I move my hand a bit, it's gonna, yeah, negative because the red, which means the red is a negative terminal and the blue is a positive terminal. All right, so I can simply switch them. Since I'm looking for the zeros, I don't really care about the negative, but yes, negative answer means, and you can see the blue is on the COM, so apparently the COM should not be on the positive. So the blue here of the voltmeter of the power supply is positive. Usually you always put blue on negative and red on positive if you need to follow up on your polarity. And it's good that you noticed. All right, now I'm gonna show you a random potential difference between 2 points, and you will see it's 2.9. It's not 0, and it's not very high. Apparently, the resistance of the paper will not give you very high potentials, which is good because the paper is safe for you to handle. We don't want you to put your hands on the paper. Your hands may be wet, and probably changing the environment will affect a bit the curvature of the electric field lines. All right, now my job is to look for zeros, and it's really bad if you don't have a plan. How would you look for zeros where you have like million coordinates to follow? So we need to start with a reference and find all the points that are zero with this reference. In other words, I'm not gonna move both red and blue pins. What do you call them? Terminals, red and blue terminals. So keep one fixed and move one, okay? So I'm gonna pick one to be fixed. I'm gonna start in the middle. Probably, if I put my hand on the paper, طلقتني الكهرباء. Actually, talking 2 volts, you're not gonna feel it. You will feel nothing below 25 volts. All right? And even above 25 volts, you will barely feel it. Don't worry. Okay? So let's continue. I'm gonna put the red terminal in the middle and check above it. Is it 0? If it's not 0, I'm gonna move a bit right to the right, a bit to the left to find the 0. If this is a 0, I'm gonna mark not my black paper, my other paper, which is a duplicate of my black paper, a point on coordinate, whatever I found, okay? So eventually I need to give you a paper with all the coordinates, and I will try my best to be as clear as possible. So I'm gonna try all the papers up and down. So I'm gonna find that this line is an equipotential line because the red is not moving, the blue is traveling along the line and it's giving me 0 everywhere. And I'm gonna repeat for all the points. Now I'm gonna move the red one box and check the blue, فوق أو تحت. Then move the red. And as I get closer to the source, I would see that the blue will not give me a 0, it's 0.2. So I should move right and left to find the 0. And apparently, if I move closer to the source, which is the left direction for myself, I will see a curve, okay? So I'm gonna move to find the 0. هون ساعة لقيتها للزيرو. Okay, I think I'm gonna find the 0 now. Okay, رجعت جربتها. Okay, هون زبطت الزيرو. So apparently I moved like 3 boxes to the left to find the 0 and mark the coordinate on a duplicate paper. So you see the line is gonna be like this as you get close to the source. Actually, to be honest, you will expect something like that. I'm sorry, sometimes you will not like it if you know what to expect. The surprise factor would go. But since I have a positive source and a negative source, you will expect gray lines like these. So you will have 1, 2, 3 lines vertical, and then as you get closer to the sources, they're gonna start curving, okay? But it's so abstract that we'd rather start with an example we actually know what to expect. And that's it. All right, so I will give you a table in which I will put all the points, all right? And you will create a map of all the points. It doesn't have to be a plot. You can simply do it on a paper, graph paper, or simply use the draw function on any app to put the points and then join them with a line, all right? Because the point is to see a map. Now let me show you the lab report. Do you think the experiment is not clear? I'm sure you're gonna watch it again and again, and probably listen to my explanation. Hopefully they are clear enough. Now, if I go to the lab report, and let me go to the manual and discuss a bit the manual with you. This is your manual. I don't know if you had the chance to look at it. Who saw the manual? So the blue terminal is positive while the red terminal is negative. I don't know, Janti. I don't want to give you the answer actually. Watch the video again. It's so easy to tell. Probably I said it in the video. All right, it's good. Can you repeat why by getting closer, the potential gets smaller? All right. No, the potential does not get smaller. All right, let me show you again. As you go and probably remove those. All right, do you see here the blue lines? The blue lines are the electric field lines, right? And as you get closer to the source, they converge to one point, which is your source. And this convergence will make the lines more radial. And radial lines, if you want to follow, let me pick gray, although this gray is not great. Let me pick gray again, gray. So I'm following and I want something thin. All right, I'm following the gray lines. The gray lines must be perpendicular. This is perpendicular. All right. So as the blue lines are getting more radial, the gray lines are getting more circular. My job is to find the equipotential line. Equipotential line means 2 points having the same potential or potential difference equal to 0. When the potential difference was not 0, I had 2 terminals. One terminal was here and the other terminal was here, just above it. So I had to move to the left, move to the left, move to the left, move to the left, move to the left to find the line of the same potential. Okay, هون ما لقيتها يمكن. You will keep on moving to the left. But if your other terminal was here, you would move to the left to find the equipotential line. How do you find it? Your voltmeter will give you 0. So I was doing line by line. Let me explain again because I know for a fact this is confusing for some of you. Let's say I want to follow this line. It is a vertical line, okay? And I know that this is not an equipotential line. I know that the voltmeter has 2 terminals. I would put one terminal here and the other one above it. If it gives me 0, so yes, same equipotential line. I keep on trying this one. That will not give me 0. If I move it a bit to the left, it will give me 0 because I am on this line. Okay, so my job is to find 2 points that would give me voltage equal to 0. So I try this point. I don't know if you can see my camera well. Okay, not this. Okay, that's the perk of using two apps. Okay.
Multiple tasks.
Yeah, can you see my camera better now? So these are 2 points of, I need to find voltage equal to 0. So I try, does this give me voltage 0? If not, I'm gonna look for the equipotential line. So I move right and left. Let me say that here it will give me voltage 0. So I'm gonna say these 2 points belong to the same equipotential line. So I'm gonna mark this point and then move up, not 0, find the 0. If this is a 0, so my line, it will be like this, you see?
Doctor?
Just a second, let me read the chats a bit. Yeah. Can you repeat why by getting closer to the potential gets smaller? So the potential is not getting smaller, the potential difference is getting to 0 because the potential line, equipotential line is curving more and more. So Karin, do you understand why the gray line is getting, it's curving? And the slide, the one where you wrote the properties.
Yes, I didn't think this. I meant the slide before.
This slide one.
Before. Yeah, no, I think slide 3. I'm not sure what I'm saying. Oh wait, no, slide 5. I think.
I think this one. Wait, let me zoom.
You gave like an example of point. Yeah, this one.
Okay. So your question is why B has a smaller potential than A? Okay.
Yes.
So I know that the proton moves from high potential to low potential. Since it's moving from A to B, so B is lower potential. This is the logic I used. So proton moves from high potential to low potential. When مكبيتي البروتون in a certain space, it has to move from high potential to low potential. And if you don't have high potential and low potential, it's not gonna move, assuming you release it without initial speed. So since we know the proton is moving from A to B, conclusion, B is low potential, A is high potential. Do I make sense?
But yes, but isn't the source supposed to be like the strongest point in the whole field?
Yes, in absolute value, but B is more negative. A is less negative. This is that's what's confusing you, because you're thinking of potential being an absolute value. Remember, potential is an algebraic function. It is a scalar. That's the beauty of it. So dealing with potential and problems is not very difficult because you can simply add potentials. For electric fields, it's a bit different because it's a vector. So you cannot simply add electric field strength. But for potential, it's easy, but it's algebraic. Keep that in mind. Okay, so let me go back to the chats. Yeah, and see, because I know there are... Okay, can you repeat why by getting closer is done? Okay, no, I meant this slide. Okay, we're fine with this. All right, I'm sure even if I explain everything, probably you are gonna have bits and pieces here and there. Let me now go to the lab report. So I open the manual and keep this close. By the way, did you have the chance to see the manual? I don't think so. Okay. If I go to Blackboard, which is here, and the manual should be here in a folder by itself, you will see two files, one doc, one PDF. I usually believe that students would like to use doc to take only the lab report section. Please don't take the whole thing, only the lab report section. And PDF is user-friendly if you're using a tablet or a smartphone. It looks better because I'm sure the tables in the doc is gonna be messed up, you know, depending on what app you will open this with. All right, that's why you have to. Now, this is the manual you expect to see. There's one chapter about introduction to error analysis. Check it out. Probably it could help you. Probably I can show it to you. It talks about systematic errors, random errors, significant figures, most of which you already know, but it's good to have a reference somewhere. And probably this reference is not enough. So don't take it for granted. I know that's enough. Okay, keep on looking here and there to fill in your gaps. Okay, you see the propagation of error. This is the RMS, and eventually we're not using this since we have now different methods. This is the error on the slope, more references if you need, and some tips about using calculators. Add to this what we have the links on YouTube, all right? Experiment 1, a very brief theory explaining equipotential lines, discussing the difference between gravity probably and electric field. I wrote this long time ago. Procedure, I think the procedure written here is exactly what I did in the video, all right? Because I did the video and I wrote this, but I never had the chance to read again to make sure there is no difference or divergence. All right, and this is important for the actual experiment. Now the lab report. So map the equipotential lines on a graph. I will give you the points as coordinates, and you simply have to put the points on the graph. So again, no need to use Excel. You can simply draw it on any app because we're not plotting a function. We're drawing a map. So it's okay if it's done by hand on a paper to scan or any app to show the drawing. Then they want you to sketch the electric field lines on your plot. Probably I should say on your map. Remember, electric field lines are perpendicular. Try to say what you did and how. Explain. Where do the field lines begin and end? If they're equally spaced, are they equally spaced at the end? Along the way, why? So you see that these somehow are open-ended questions. Sometimes you try to explain a bit. Don't get frustrated. It's mostly description. What approximately is the potential midway between the two conductors? Here I can tell you have many answers to this question. You should start with an assumption. I know the potential difference between the sources is 20. It could be minus 10 plus 10. So you can say, I assume that the potential is minus 10 plus 10 for the sources. Therefore, the midway is whatever. Or I can assume it's 0 and 20. So just explain. Don't worry about what your answer would be, because I worry about the way you analyze it and the way you explain it. I don't care what will be your final answer, all right? Unless it's really odd. Where is the electric field the most uniform? How can you tell? Some questions are general though. The potential is everywhere the same on an equipotential line. Is the electric field everywhere the same on an electric field line? If you rest your hand on the paper while making measurements, does it affect the readings? Why or why not? All right, some of these questions require some reading. Like, I don't know, for example, is it possible for different equipotential lines or two lines of force to cross? Why or why not? You don't need to do readings to answer this. If you know the definition and what is an equipotential line and use a common sense, you can simply give an answer and explain it. But this is a famous question. You can find it in any textbook. So it's okay if you take a week and think about it and probably read in your book or read some easy online material, all right? So don't be in a hurry to answer those. Sketch the equipotential lines for an isolated positively charged particle. So this is one example not related to your map. But keep on reading, spacing the lines to show equal difference of potential. Okay? When the equipotential lines bend, what happens to the electric field lines? How do you relate your map? And so on and so forth. So that's it. You have 9 questions in here, and those are directly related to your map. As you can see, this lab is qualitative. It was meant to be qualitative because it's the first lab. This is not an assignment, Sherbel. This is your first lab report. So yes, it is graded. And yes, you have unlimited submission, which means I don't want you to freak out. Worst case, you simply submit again. All right? لا مش كلهم بيجوا هيك. I want to show you lab number 2. Lab number 2 is gonna be regular. By the way, lab number 2 is time consuming. So you should know from now. Lab number 2, you have table of measurements, fill, plot, linear regression, error, compare, comment, another table, compare, another table, calculate, comment. All right? So this is regular. Okay, ما بدهم كتير على Excel. If you know how to use Excel, you will be fine. If you don't know how to use Excel, I think lab number 2 will be very important for you. Even if it's time consuming, it's worth it because you will learn a lot and you will fill in all your gaps. For lab number 3, it's gonna be easy. And then lab number 3, you have a lot of RMS errors and averages. Find the average with the root mean square. كتير هينة هيدا. ما بدهم كتير شغل. All right, this is easy. This is Ohm's law, resistance and resistivity. All right, so please, if you believe lab 1 is tough, it would be frustrating for some of you because it's very theoretical, conceptual, and qualitative. Let me know. I can give you hints. Probably I can help you with a question or two. For lab number 2, there's a lot of data analysis, but probably it will be your only chance before the midterm to learn all the material in data analysis. So don't block it and don't ask your partner to do it for you. Remember, you're gonna do that in the midterm. So take it as an opportunity for you to try. Because if I jump to lab number 4, there's no data analysis at all. So it's like lab number 2 is your only chance. Let me show you lab 4. Lab 4, where is lab 4? Yes, I was guessing right. Circuits and bulbs, you're gonna play around with bulbs and you're gonna discuss the brightness of a bulb. This is descriptive. Brightness, like brighter, less bright. And the questions are so like draw a diagram. What happens if you reverse the wire? Here, I will do the whole experiment on video. You watch the experiment, you see the observation, you write it here. Like I'm gonna do the experiment for you. It's a long video. You pause, you write, you pause, you write. We're talking light bulbs and brightness. So I don't see measurements. I don't see average. I don't see plot, linear regression. Okay? And conceptual. So lab number 2 is gonna be your best practice, your best workout. Okay? Now let us focus on lab 1. Yes. And by the way, the deadlines from now on are not gonna be Friday evening. They're gonna be Saturday evening because I want to give you a chance to ask questions during our live sessions. So next Saturday, I expect you to be done with the lab report probably, but not finalizing it until we meet. So maybe you need to say something or talk about something or discuss something, you know? So extending it by 24 hours, I think it's good. It makes so much sense. Yes, someone who was talking.
دكتور عبده عم
Yes.
بسألك إذا فيك تقولي لنا شوي كيف الإكزامز رح يصيروا، لأنه كل ما يكون في فيزيكس لاب كل يعني حسب كل انستراكتور بيتغيروا الفحوصات، في يعني في كتير confusion عن قصص فحوصات الفيزيكس لاب.
Yeah, I know, and I also know that last semester you had a big deal for your midterm in Physics 302. I have one thing for sure to tell you. You are the only section and I'm the only instructor. So probably communication between us is going to be easier. Probably, yes. And give me a week or two to see how things would be. And let me try to describe the midterm as accurately as possible. Okay?
Okay.
And maybe give you something to practice on. Okay?
Thank you, Doctor.
Yeah. I think communication is key. If you keep on communicating your weaknesses, your worries, your questions, meetings on a weekly, daily basis, I think it's gonna be good. I don't know. Let's try. But don't keep something for yourself. If you don't know how to do this and you don't want to talk about it in the class, talk to me privately later on, okay? And please do not wait to cover up your gaps. I'm not talking about you, Abdo. I'm thinking about Lean. Because Lean would think at some point she has a gap here and there, and probably she would say, it's okay, I can cover this in March. No, please don't wait on your gaps. Assignments, you should know how to do it. There's a part you don't know how to do. It's now is the right time to fill in your gap. Don't wait until next week. And that's what assignments are for, actually. Yes, any other question?
ما تعطى للين يا دكتور بأمانتي.
انت هيك بتقول، بس يمكن لين بينها وبين حالها عم بتقول هيدا شرب الخنقني مش طايقته. يمكن، ما بعرف.
لا
هي أكتر.
Lean, you're lucky you have Sherbel, but keep in mind that Jessie can answer some of your questions as well, okay?
Yes.
Good to have
Thank you, doctor.
You know, and sometimes if you have Sherbel, you would rely on him and you will feel safe. And when you're on your own, probably it's gonna be more difficult. So try to repeat things on your own as well. All right?
Okay, doctor.
All right. I'm gonna stay a bit if anyone has a question.